Welcome to this first workshop of a series that CASTIEL will organize. We hope equally we hope to your best wishes for this new year if we are by end of January. So CASTIEL, generally, the WP3 CASTIEL activities aim to enhance the visibility of HPC training opportunities across Europe, foster collaboration among NCCs and COEs, and support the development of a pan-European training ecosystem. So to keep pace with technological development, we have decided to extend our actions to emerging technologies such as quantum computing. So CASTIEL 2 WP3 is kicking off a new series of workshops to pinpoint the skills gap in quantum computing and prepare the next generation of engineers. So for this first workshop, we are seeking the views of users and industrials on the skills and training requirements for quantum computing. Today, we have 5 presentations from Systematic, IBM, Thales, Crédit Agricole, and IQM. Each presentation will take 20 minutes, including a question-answer session of almost 5 minutes. We also will end the presentations by an open discussion and question to the presenters. So let's start by the first presentation, which is made by Daniel Ver from Systematic. The topic is From Theory to Practice, Skills and Preparation for Industry Transformation. Daniel is the coordinator of the Advanced Engineering and Computing Hub at Systematic, a competitiveness cluster dedicated to deep tech. With a PhD in quantum computing and a specialization in quantum technologies, he leads and assesses the ecosystem of collaboration between startups, researchers, manufacturers, and industry institutions to accelerate the development of quantum and HPC technologies in France. So I let the floor to Daniel to start his presentation. Please, Daniel.
Thank you, Tamir.
Okay. Yes. You can share your slides.
Okay. Okay. Good morning, everyone. My name is Daniel Ver. I'm a coordinator of the Hub Advanced Engineering and Computing. I am delighted to present this session tailored from theory to practice, skills, and industry transformation lines.
Daniel, if you can use the full screen option.
No, not possible, sorry.
Thank you.
Quantum computing represents a significant leap, not only technologically, but also industrially. It has the potential to profoundly transform sectors such as healthcare, finance, energy, etc. However, this revolution cannot materialize without a robust ecosystem, and more importantly, without the right skills to harness this new technology. My goal today is to outline the framework for this discussion around 3 key points. One, understanding the quantum ecosystem and its key players. 2, identifying the fundamental and specific skills required. 3, proposing strategies to help companies anticipate and integrate these technologies. This introduction will lay the groundwork for the following presentations, which will delve deeper into these topics within a specific context. Before discussing skills, let us first understand these players and technologies that form the quantum ecosystem. This ecosystem is built on the collaboration of various players working to turn scientific discoveries into practical applications. On one hand, we have academic institutions conducting fundamental research on topics such as stable qubits or advanced algorithms. They produce the theoretical advance that make this technology possible. Thanks to their work, companies like Candela, Pascal, etc. have emerged. Next, there are large industrial companies such as IBM, which provide practical tools like Qiskit to make quantum programming accessible. These tools allow developers to test quantum algorithms on simulators or real hardware. Such companies play a crucial role in transforming innovation into tangible industrial solutions. Another key sector involves identifying use cases for large corporations, which I will touch on shortly. We also have startups specializing in niche areas like photonics qubits for ultra-secure communication or quantum cryptography, etc. Where their focus is hardware, software, algorithm, sensors, telecommunications, or cloud computing. Sorry, they form the fundamental of tomorrow's quantum technologies. Finally, governments and consortia support this ecosystem through strategic funding, such as the EuroHPC, which structures and accelerates initiative at the European level. These players are really on three pillars. One, hardware, technologies such as superconducting computing, trapped-ions, photonics, etc. Software, developing algorithms tailored to specific problems. And three, application, targeting key sectors such as healthcare, finance, etc. Understanding this ecosystem is essential to grasp the importance of the skills required for its development. Now let's us focus on the fundamental skills that underpin the development of this ecosystem. Why are skills critical? Facilitating collaboration without a shared understanding among your research, engineers, and decision makers. Translating research into applications is slower. Collaboration tools, initiative, working groups, and ecosystem interaction, HPC, AI, tensor network, etc., is essential for mutual learning. Reading theory and practice. For example, concepts like superposition and entanglement must be translated into industrial solutions to optimize the processes. Take Candela, for instance. How do we move from the concept of a single photon to building a photonic quantum computers? The ability to transition from fundamental physics to industrializations is a vital R&D skill. Okay, key foundational skills include mathematics, mastery of matrix and vector, which are fundamental tools for describing quantum states. For example, Pauli matrices are used to represent quantum oscillation, and quantum programming tools like Qiskit, Circle, Pulsar, etc. enable the design and the testing of a quantum algorithm, either on simulators or real hardware. And data analysis, quantum computers produce the probabilistic results, requiring expertise in processing data to interpret these outputs correctly. Beyond technical skills, transversal skills are equally critical. The ability to explain complex concepts in simple terms is essential for identifying use cases. For example, Crédit Agricole in France trained teams to integrate quantum computing into their risk analysis processes. Okay, why are these skills so crucial? One of the primary challenge of the quantum ecosystem is the gap between the demand and the supply of talents. According to recent data, 30% companies report difficulties recruiting qualified experts. The sought-after profile include quantum hardware engineers capable of designing stable qubits, for example, algorithm architects specializing in developing solutions for specific applications. To address this gap, several initiatives have emerged. For instance, EQM trains technicians specializing in qubit calibration, critical task for ensuring the performance of quantum computers. Hackathons provide teams with opportunities to test their skills on real-world challenges, such as logistics optimization or financial risk reduction. In summary, developing these skills is not just a technical necessity, it is a prerequisite for fully harnessing the potential of quantum computing. Okay, let us now dive into the technical skills specific to the compute layers. Mathematics, understanding unitary transformations and the density matrices is essential as they describe how quantum states evolve. Physics concepts such as superposition and entanglement are fundamental. These principles allow qubits to correlate and solve complex problems theoretically faster than classical computers. Programming using a specialized data structure to code algorithms like Shor's for RSA encrypting or Grover's for efficient database searches. Adaptability, rapidly acquiring new skills on evolving platforms is essential to keep up with technological advances and maintain competitiveness. When combined these skills, enable industries to maximize the performance of quantum systems. Industry, the central question is how can this prepare to integrate quantum technologies? For the first step is to identify relevant use case. Finance, quantum algorithms can optimize investment portfolios. Elsewhere, accelerating drug discovery to rapid simulation of molecular interactions. Energy, optimizing electricity grid to reduce losses. Logistics, planning more efficient routes, thereby reducing costs, etc., etc. Concrete initiatives such as hackathon, conference, seminar, and trade show allow companies to explore, test, and evaluate the potential impact of quantum use cases. Clusters like Systematic play a vital role in fostering this connection. Okay, in conclusion, sorry, it is the time for companies to take action. Here are 3 concept steps. Train your teams, invest in tailored training programs to equip your talent with quantum computing skills. Collaborate with the ecosystem, join technology hubs, or work with startups to co-develop specific solutions. Experiment, launch pilot projects, or participate in events to understand and test practical solutions. Finally, begin anticipating the kinds of problem quantum computing can solve for non-specialists. Quantum computing will not solve everything, but it will become an integral part of many industries. Okay, I finished. Thank you for your attention. I invite you to explore these opportunities to transform your industry. If you have specific questions, please do not hesitate to contact me directly. And thank you so much.
Thank you, Daniel, for this presentation. We move to questions. We can move to the second presentation, which deals with skills for the compute part of quantum computing, and which will be made by Pierre Jagger from IBM Quantum. Pierre is the technical director for strategic partnership at IBM Quantum, focusing on European collaborations. With over than 17 years of experience in IT, including roles at the CEA and IBM in scientific computing, systems architecture, and project management, Pierre brings a strong technical background to this role. He holds a degree in mathematics and digital computing from Polytech Sorbonne. Please, Pierre, can share your screen now. Yes.
Perfect.
Thank you.
Sorry for that. Then yes, I will separate this presentation into stuff very shortly, set the stages of not what IBM is doing, but the kind of stuff which is part of the compute side of what we are doing, and focus a little on our initiatives that could be from interest for you in terms of skills, and that is clearly, and we can say that upfront, not sufficient. The tremendous demands of skills in the quantum part, and especially in the algorithms part, are more than what we can find on the market, especially from an optimization standpoint, software development, and other kind of capabilities. Anyway, that's the reality of where we are today. Then, the way we split and we see quantum computing in IBM is that quantum must be performant. Okay, that's an obvious point. Second point is that quantum must be easy to use. When we see easy to use, is that if you need to have a PhD in quantum physics to be able to use quantum computing, we will miss the target. At the end, we do not own, each of us, capabilities to understand how HPC centers is working to take advantage of HPC simulations or large grid simulations. Once again, how we divide that, we do believe in IBM that we need to have a very good software interfaces. We strongly invest in our ecosystem, strongly invest in Qiskit. Systems, yes, IBM's one, but maybe not only IBM's one. There is other partners in the world, and that's software plus hardware that will reach that to work. I will be a little provocative, but I will use the word of my boss, is that from an hardware standpoint, we deeply think that doing something which is simulable on a laptop is great to learn how to develop, but not to learn how to develop on a real quantum computer. Then we are a little pushy on that. We know that, and we strongly believe that what we call non-simulated easily or non-brute force systems need to be worked and need to be addressed. I won't deep dive on the IBM's roadmap, and I think that will be all from an hardware standpoint, and I will only focus on the second part, the orange part of that chart, which is how do we map interesting quantum problems to quantum circuits? How do we take advantage of the quantum computer, and how do we envision problems that could be run on a quantum computer? First, I think we all need to forget that there is only the long term. There is also short-term work, and a lot of company, IQM is in this call, Daniel mentioned Pascal, mentioned Candela, they already produce hardware, as we do, different level of capabilities for each companies, that's how it is, but we all think together that there is a near-term practical value, at least to begin to work on real quantum computer right now. And it's much more, what are you doing with this new tool? They are maybe not perfect, but just reverse the way, take your problem and see what you can run on today's quantum computer, rather than saying you can do 100% of the potential problem. Last point is that you need also to think about the solvable problems, but also the interesting problems and what could be done when. And a lot of people are only thinking about solvable problems. In the future, if I have a 1 million qubits, whatever, I will do a lot of stuff. And then you just not concentrate on the reality and on the business value short term. What is the timely problems? And the risk for that is that other people could do and could focus on timely problems. I do believe in the ecosystem. We do believe in the ecosystem. We have a large partner of ecosystem. And why I'm showing you that is not because the impressive numbers of people that are working with IBM technologies. It's because these people needs more competencies. And they need more competencies because, and it will be very fast, they are working with difficult architecture. How do you run your open and classic resources to access quantum computer? How do you use AI to enhance the way you will develop on a quantum computer? Then you need to have capabilities to prompt and to be able to prompt, and you need these kind of skills. What is a good prompting to generate circuits? How do you work with add-ons, with already part of the code done by others? I take the example of IBM, but it could be others. How do you aggregate other parts coming from multiple partners in this world? Last point. How do you contribute to the ecosystems? A lot of people don't have the resources to contribute to GitHub communities. Whatever is it Qiskit or is it others communities? And that's why if we increase that, we do believe the quantum software on top of what Qiskit can provide is very, very important, and we need to put a lot of emphasis on that and a lot of skill on that. I will forget that. Let's forget also the stuff. Then our vision of quantum workforce. We do believe that there is an incremental need to have and to give capabilities to hardware, software, and tools. There is not enough systems installed in Europe. There is not enough enterprise and public and private entities that have capabilities to say to the researchers, let's go and let's do something on real quantum hardware. Second point, education. That's obvious. That's why we are there today. What are the resources that are available? IBM, we are not an educative company. That's not our DNA. We are not giving a license at the end. We can give badges, but that's not our job to educate people. But we need to do it as a community, and that's the last point. Embrace that as a community. That just point for you. New learner and new generation learn a lot through YouTube's video and through video. We made a huge effort on that. The number of you is impressive, but it is once again Qiskit centric. Then maybe we need more on that, not only Qiskit. We propose a platform, the IBM Quantum Learning, but we are not teacher. We cannot go to every school. Then we need to teach the teacher, and we need to create a kind of learning path. What kind of learning paths are useful for the future students? I put you some of them: getting started with software, understanding the quantum information and computation, scaling quantum computing toward utilities. How do you scale your small toy problem that you can run on a laptop, 5 qubits, 10 qubits? That's something you can run on a very old laptop, to hundreds of qubits. That's something that you will not be able to simulate anymore. That's not like that. That's another kind of stuff. And another point that maybe a lot forgets, but quantum business foundation and application. How do we train the people that will take the decision that quantum is important? Because if we want to have a successful European ecosystem, we need to have people that invest time and money in the quantum world, but not only from a creator of quantum computers, but as a user. And what are, you mentioned Crédit Agricole, Andrea is there. That's a good example. They invest time to train their steering committees to understand what is quantum business foundation and applications at a senior level. That's something that is also mandatory and that we need to develop. Then is also the community. We have a lot of hackathon. That's a good stuff in Europe. We need to increase this kind of stuff through developer certifications. How many certifications do we have externally right now, not owned by private companies, to increase the number of people that are able to talk about quantum computers? And I think that's all. I'm there to take any question if you have.
Thank you very much. Any question? Let's move now to the third presentation made by Frederic Barbarescu from Thales Group. The title of the presentation is Skills and Training Needs for Quantum Computing. Frederic leads the quantum algorithms and computing segments at Thales, overseeing research and technology activities and fostering partnership with deep tech startups and academic labs. He coordinates projects like BAC, organizes international seminars and hackathons, and contributes to industry standardization efforts, including the IEEE Quantum Computing Benchmarking Group. Frederic received the 2014 Amy Warson Prize and is an emeritus member of SEE. Thank you. Please, Frederic.
Thank you. Thank you. Share. Okay. So this is very synthetic. I have only one slide. So the question was about skills and training needs for quantum computing. So for the time being, in Thales, we have almost more than 20 engineers working on a quantum algorithm in coordination with our business line. But we have a very large community of people working on classical algorithms. So we have a few thousand of engineers in Thales working on a classical algorithm for sensor and system. So we want to beneficiate of these skills in our company. But the skills needs, so to acculturate these engineers, we need skills for about tools for QPU emulation. So especially FTQC, because for the time being we have not access to fault-tolerant quantum computing. We have to acculturate our engineers to this technology and to use emulators to do that. Sometimes also to be able to emulate also the noise, and so how to include a noise model in quantum computing emulation. the programming language and framework. So the difficulty for the time being is that for quantum annealer, NISQ, and FTQC, they are not using the same algorithms on not or sometimes the same programming language and framework. So to acculturate to all these three family of quantum computers on as much as possible hardware agnostic. So we are not dedicated to one technology and want to use this programming language and framework for hardware agnostic technology. The next topic that you make reference also is we are interested is hybrid QPU CPU programming. So it's perhaps this technology of Pragma, where we can in a code indicate which part will be processing on QPU, one part will be on CPU, and to develop hybrid QPU CPU programming. For FTQC algorithm, for the time being, we have very short list of existing algorithm. So we have HHL for linear system solving, you have Shor for factorization, and so we have not so much on, we're interested to develop new algorithms, not only using algorithms, beneficiating of our very large community of engineers working on advanced algorithm. So for that, we are to use advanced mathematics, which are not used in classical algorithms about Lie algebra, Hilbert space, étoile algebra, so new kind of algebra mainly. So it's not so obvious. So we have we need some skills for this advanced mathematics for especially FTQC algorithm. For NISQ and quantum annealer is more classical, but for advanced mathematics it's more difficult. About resource assessment tool, also some skills to use in the best way a resource assessment tool, because we have our engineers have to work on the scale up of this kind of algorithm for our application. And for the time being, we have not we have a very small number of qubits for existing quantum computers, and so we have to try to extrapolate the performances and so to use resource assessment tools to map with the QPU provider roadmap to know exactly when the scale of QPU will be available for application. So it's mainly for quantum computing at scale. For quantum algorithm engineering, so in Thales, we are working a lot on AI algorithm engineering. So how to develop methodology and tools for programming QPU. So we have not debugging tools for QPU for the time being, so it's not so easy. Also, Thales is developing critical system. For critical system, we need some norm and standards of validation and qualification, but also methodology. And in support of this methodology, we need some tools of engineering this algorithm. We have done that for AI algorithm in the program Confiance.ai in France, where we are working with other industry to develop methodology and tools for validation and qualification of AI. And we should have some also skills also for quantum algorithm. And also among that, you could have some formal method for quantum algorithms. We know that, for instance, CAA in France has work on Kubrics, which is to extend a formal method for code qualification dedicated for quantum algorithm. So this is the needs for on or engineers that will be dedicated for that. What we have observed that in France and in Europe, we have not so much people working on algorithms. There is many laboratories using algorithms on use cases. But inventing the new algorithms, it's another task, and we have to develop skills also in laboratories to have this capacity. And so the second topic about training needs, as I said, there will be a difficulty to have talents, because we have a frugal resource of talents, and so Thales will invest also on training, and we have to train our engineers. So we have a few thousand of classical algorithm experts, and we have to train them to transform them as a quantum algorithm expert. And so they have some high skills in advanced algorithms, so they can learn very fast, but we need some dedicated. So on quantum programming, and also on use of existing quantum libraries. So there is many libraries. Some laboratories are developing also some libraries on how to use all these libraries, on also the quantum programming language. So you could have different. You can program a quantum computer at a high level with Python. So I could say as a zero level expertise in quantum programming. So you use a function as that will be a process on a QPU, but you don't know exactly how this function works, but you know that you have to specify some input, and you will have some output of the algorithm, but you don't need dedicated skills to use it. So you could have a module of optimization, for instance, and you use a module which is a quantum algorithm that will be compiled on a QPU. But if you want to modify the algorithms, you need to program at a lower level, and we need some skills in quantum programming. So it's not initial training, but we need training for Thales engineers, and especially on these two topic, quantum programming and the use of existing quantum libraries. Okay, so this is mainly the main points Thales would like to express in terms of skills and training needs for quantum computing. So thank you. If you have some questions.
Thank you very much, Frederic. Thank you very much.
Thank you.
So now we have the fourth presentation, which is dealing with preparing a big banking group for the quantum era. It will be made by Andrea Levaux from Crédit Agricole. Andrea is a quantum activities coordinator at Crédit Agricole Group, leading the exploration of quantum technologies through the lab New Territories. With a background in startups and innovation, she bridges theoretical advancements and practical applications to shape the future of banking and finance. Please, Andrea, it's up to you.
Yeah, thank you, Samir. So let me share some slides. Maybe a few words. First of all, a few words to Crédit Agricole, so that you have a better view of that. So the Groupe Crédit Agricole is one of the largest banking groups in France and in Europe, with a unique cooperative structure. So we are composed of a central entity that is called Crédit Agricole SA, listed on Euronext, Paris Stock Exchange, and around we have 39 independent regional banks. And each regional bank is a mutual cooperative bank that collaborates with the central entity and each other. So we are a very, let's say, a traditional bank, a very old bank. So we were founded in 1894 to support the agricultural sector in France. That's why the name. And we have since expanded our services to include a wide range of financial products and services for individuals, business, and institutions. Today, the group offers a comprehensive range of banking and financial services, including retail banking, corporate banking, investment banking, asset management, insurance, and leasing. So this is why we are also looking at quantum technologies, because many of these services use complex mathematical models. So let me change to the next one. So I'm coordinating out of the lab New Territories, where we have a look at disruptive technology. So more not what is, for example, we're not looking at AI. We are looking more at what will be important from 3, 5, 10, 15, 20 years from now. And within this scope, we are also exploring quantum technologies. So like other big banking groups also. So for us, it's really to enhance operations and services. So quantum computing in particular, on the computing part, is rapidly advancing. And we believe that it will revolutionize various aspects of banking, including risk management, portfolio optimization, and cryptography. But it will also impact all our clients, because it is a phenomenon of society. It will be a really revolution that will impact everybody. And so we are not looking at it only for our own purposes, but we are also looking at it for what it will mean to society. So on the slide, you can see our 5 pillars of quantum strategy. So first of all, certainly we heard it also from others, we still have a great need of acculturation. Why? To prevent both the quantum hype and the fear of quantum. That's why we need to educate our co-workers, and we are also even reach out to educate and to work with some of our clients that are also involved in the field. So these the acculturation involves creating a realistic understanding of the opportunities and risks associated with quantum technologies. So the next pillar is training. So training is more for an expert kind of group. So to develop a small group of internal experts to identify and to optimize the use that we can do with quantum computing, and progressing with the technology that's going further. So this involves also deep training in both quantum inspired and quantum algorithms. I come back to that later for the skills and training needs. So then we also do one of the next pillar is experimentation. So to experiment with identified and prioritized use cases that what we can optimize today with quantum computing, or also with quantum inspired. So this helps us to validate the potential benefits and challenges, and to get some hands-on experience for sure. Then another pillar for us, very important, is the ecosystem integration. So to really build strong relationships with promising startups, with organisms, with other corporates also that work on this field. So that is really to help to build a strong relationship and to help to emerge this ecosystem in France and Europe is also one of our main aims. And this involves also active participation in the quantum ecosystem and collaboration with the leading quantum technology providers, the associations, etc. And then one last pillar that is still a marginal field for us today is to explore opportunities to support startups with investments, so in emerging quantum technologies. So what are really the status now and our needs? So today we consider that quantum is still in an R&D phase. So we are a bank, so we're not doing really R&D. That's not in our scope. We focus more on concrete applications, so that can provide immediate value to our operations. So in In the past, what we did to come to this, so we to ramp up slowly in our knowledge, is we created a community about 3 years ago. Within this community, we educate co-workers on quantum computing. So it's acculturation training. It's little, there are different groups, let's say, with different focuses. And the members of this community are really coming, and that's really nice, out of all different out of all the groups. So they're coming from the investment bank, but they're also coming from the payment service, even from retail banks. So we see that there is a great interest in these technologies, and they also come from all kind of let's say level of hierarchy. So we have from collaborators that are working in retail banks up to the highest management who participate in sessions. So in these sessions also we are inviting startups so that they can provide members with insights into different applications, use cases, and technologies. And for sure, well, you maybe have heard of it, we already conducted also some experiments on early quantum computers and quantum-inspired algorithms to improve our algorithms that we already use in our models. So let's go further here. So the question is, what are the skills, the specific skills and training needs to further develop quantum at Crédit Agricole? So still the priority is certainly acculturation. So to continue to provide a realistic understanding of the opportunities and risks of quantum technologies. So this is really crucial because quantum computing gets more into the media. We've seen lately for example, the new chip Willow from Google that was really hyped in the media, and it's for non-experts, it's really difficult to make the difference from what is hype and what is real. And some also have this fear of quantum technologies. We work a lot with, well, data is everything for us, so that this will not be safe. And so the challenge is really to adjust adjust the knowledge and to always give updates when there are really big changes. So then the next is at the expert training. So the expert training, we are similar. We're working on similar mathematical problems like Thales, like Frederick mentioned earlier. So we have these. So we try to do deep training in both theoretical and practical aspects of quantum computing. So some of the trainings are using platforms and emulators with publicly available libraries. And one need that is getting stronger and stronger, what we feel stronger and stronger, is really to address the mathematical knowledge. Donc to address the whole field of quantum-inspired approaches also, that allows to see a lot of mathematical concepts with very concrete applications. I'm thinking about approaches such as tensor networks and how to go from one to the other, really to that includes also to be able to detect where quantum is the right solution and where it is not, and how to combine quantum and non-quantum algorithms. So that's really something that is getting more and more evident that we need to address that. And for sure, the practical experience. So there's really one thing on the, that's something that we need to more promote in the next years, because it will be more important to train a broader circle of co-workers to get hands-on experience, like with the platforms, with emulators, with quantum computing platforms. And this practical exposure is really the key to understanding the limitations and potential of current quantum technologies. So less on the physics part of it, but really more on the practical application. So practical application and algorithm algorithm application and in a certain degree also algorithm development, even if we know that this takes time and it will still, we're still still at the very beginning. And as soon as we identify best practices, for sure, it's important to multiply that, to promote it, and to standardize these practices across the organization. So maybe a few words to the reason why we care about quantum in this early stage. So we believe that quantum technologies will be a real game changer in the not so far future. For sure, when you think of a bank, often use cases are seen as data security, so that's a risk. Sure, the usage of quantum safe algorithms, we need it to protect the data. That is a critical topic, so no doubt. But I also see other risks like competitive risks. So any advancement in the field of computing can potentially turn into a competitive advantage or new opportunities also, not only in investment banking, but also in many other fields. And the quantum computing holds really a significant promise in this field that the financial industry cannot neglect. And on the other end, for the real opportunities, as I said, we believe that we see a lot of use cases already in computational finance, in risk management, and in portfolio optimization. Those are really use cases that we can work on right now. We don't have to work. I agree with Pierre earlier. We don't have to work that we have these quantum computers that have hundreds of qubits, etc. Now we can already start to do to tackle these real life problems, maybe with still with toy models, but step by step we are ramping up, and we believe that in the next 3 years or something, we will already, because we have already optimized some algorithms with quantum inspired also, so that these will really go into production, and and going further, that we will maybe have new avenues for innovation in financial products and services that we do not see now. And for sure, one thing that I did not mention before, I think it's a strong environmental concern. So I think you all make the experience right now with AI that the computing volume is really exploding. So we are using AI since a couple of years already, and there's a strong environmental concern. We want to use these new technologies, but not at any prices. So there is a limit where we cannot just go further and further and use more computational power. That's just from an environmental point of view not possible anymore. So we need really to have a look at also how can we outsource parts of computation in the near future to quantum computers that at least promise today to be less energy consuming. And so this is a real motivation also to further look and to train and to see to introduce quantum computing as soon as possible into our workflows. So as conclusion, we can say we believe quantum computing holds significant promise for the financial industry, particularly in risk management, portfolio optimization, but there are many other models, mathematical models that we use today that may be optimized. It is important for us to start now and to stay on a path of continuous learning. So this is really crucial for staying ahead of the curve and maintaining a competitive edge. And as said, the fields of what we need to train is really acculturation, expert training, mathematical knowledge, practical hands-on experience, and promote best practices. So, and by focusing on these areas, we believe that we can effectively prepare a credit call for the quantum era and ensure that we remain at the forefront of technological innovation in the financial industry. So I'm open for any questions.
Thank you. We can move to the last and not least presentation. which will be made by Stefan Sigurer from IQM. It's entitled Separating the Signal from the Noise When Learning Quantum Computing. Stefan is head of user experience and engagement at IQM Quantum Computers, where he helps people integrate quantum computing into their solutions. He's an experienced educator. He has led over than 100 workshops and created learning materials, earning recognition such as the AI Newcomer Award in 2021. Thank you. Please, Stefan.
Thanks for having me. And great that you are still around after like 1.5 hours of session. So I think that's well, yeah, 1.5 hours. That's roughly it. So that's great to see. Actually, I actually forgot which title I mentioned. I changed it slightly, but it doesn't really matter because the latter part that was mentioned is still in there. So I'm from IQM, but actually I have literally no slide that is advertisement for IQM and that explains what we're doing. So maybe I should say that we also build quantum computers and superconducting technology, and we do have a very diverse workforce, I think, and this is where the updated title I made here was coming from: physicists, computer scientists, and watchmakers skills to make it in the quantum industry. And I think I chose a little different approach in kind of this presentation I'm now doing, because I was coming from this question that was given to me by Marie about what are actually the skills we think as an industry player are needed. What are we looking for? And this is kind of, well, it's a question that I can't fully answer because it always depends a lot. I tried to nail it down to a bunch of concepts, and these kind of takeaways I hope will help us to reflect the day-to-day and hopefully get some inspiration for the futures. And the promise was real that actually we do have a bunch of watchmakers that have learned the craftsmanships of making watches, working now on building quantum computers. So this is an article from Enter Espoo, Finnish, like Espoo is a Finnish city where we're based out of. And this was reporting on like the people at IQM that work on building quantum computers. Marcus and Ville both mentioned that in this article are colleagues of mine, and both graduated of this watchmaking school. Now Marcus is building quantum computers for deliveries, while Ville is performing some tasks in the clean room on creating those chips. And I guess what's kind of funny is that Ville says, okay, I don't fully understand quantum computing either. And I think that's totally fair to say, because there are so many different tasks within this industry. To give us a kind of feeling, understanding of what type of skills we're into, or in general are helpful to have in this industry, I was thinking I'll just walk us through our recruitment portal, our job ad. Probably not as long as some other lists, but if we go there, we find, for example, the quantum hardware engineer for device design. And there we mentioned, okay, it's about developing new quantum processing units. And this team is consisting of physicists, simulation experts, software developers, kind of to automate that process of designing the chip, because also a chip is designed in software. The skills needed, well, ideally it states a PhD in physics or equivalent level of experience in a related engineering field, expertise in one or more relevant physics fields, such as superconducting qubits, quantum computing, quantum physics, microwave engineering, and good understanding of Python programming. This is kind of a hard skill, and interest to improve software development skills, attention to detail, striving to deliver blah, blah, blah. But I think what we can see here already is how interdisciplinary this is, that probably there is no one that can bring in all the expertise at once, and that this is a field of constant learning and improvement. And this is not just true for the hardware design or QPU design, chip design, but also for, well, production engineering, where it's about maybe troubleshooting production issues, liaising with cross-functional teams, and all these kind of things. So here it's about doing the stuff in the clean room, executing wafer level QPU fabrication, and so on and so forth. The last example I brought was the quantum algorithm engineer, because this was the one that was spoken about mostly. And as apparently this seems to be the focus part of this group, I want to dig into this one more deeply. And then we'll see, okay, what do we, but essentially everyone else is looking into. It's about developing new or improving existing quantum algorithms. It's about implementing them, potentially on our hardware, but just about implementing them. It's about speaking about those. And what we're looking into is people that understand quantum information theory, quantum algorithms, that have been seeing a bunch of these algorithms and have proof of experience. Ideally, we look in the form of scientific publications there. And I think what this shows us is it actually doesn't mention with what you're implementing this or anything, because that doesn't really matter for us. I think for us, it's really about the concept behind that you got those nailed. So kind of what I see is, okay, skills, they vary drastically depending on the role you're kind of looking into. I think you can get into quantum computing as with a lot of different backgrounds. We've seen watchmakers, software developers. Okay, they're pretty straightforward. But actually, for example, I studied to become a math and computer science teacher and ended up to work in a quantum computing startup, which, well, life changes. But I think it shows there is not that one trajectory, and that makes it even more complex for kind of education. And what is also pretty prevalent, I think, is that meta skills are often more important, like this independent problem solving. And I remember the question I asked to Pierre, he also mentioned this, that it's literally about the skills of scaling up those systems, like things people have not been doing before. So it's not that you can have a formal training of how to make the fridge house, I don't know, 2,000 cables and still cope with the heat introduced by those. So I think those meta skills are actually very, very important and are hard to kind of make tangible. I mean, we all admit that I think one of the most important hard skills, independent if you're a physicist or a computer scientist, is that software development and an understanding of quantum algorithms is pretty helpful, pretty useful. But so I gave you now a lot of maybe thoughts. Maybe it was too loose to even get a hold of. But what I think is the question that comes out of this is, okay, blah, 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 meta skills, that's all nice. But what do I actually teach? I mean, if I'm a educator, I need something concrete to teach. And how could we think about that? And I will not give you the 5 concepts you need to teach in your quantum computing lesson, lecture, or tutorial. But I want to make you think about the following. So for anyone entering into the field of quantum computing, I think there is a lot of, let's call it noise, or vocabulary in that field of quantum computing that is pretty overwhelming for someone transitioning from another field into quantum computing. And just on this slide, there is a bunch of things that maybe in this room seems to be pretty obvious. But if you show this to your best friend who is a, I don't know, software engineer building databases or web services, I would assume that maybe 1 or 2 words sound familiar. And the thing is, how do we navigate this maze as like educators? And in order to figure that out, or to give you a thought, I want to invite you to join me for a thought experiment. And I would just ask you to kind of remember the encoding I present to you on this slide. Say 1 minute is like enough. And please no screenshots. I know we're in Zoom and you can all cheat. Okay, actually, I mean, telling from the discussion before, this room seems to be pretty clever and pretty knowledgeable, so I think the time I gave you was already enough. Is there someone around who could decode this for me? Those four characters. Okay, apparently it's not that easy.
Too fast. Sorry.
No, it's good. Actually, I did this on purpose. I would have been surprised if you figured it out. It's 3147. And for me, it feels pretty easy, mainly because I can look at the solution. But if I, instead of this strange encoding that, by the way, thank you, you learned like lemmings pretty nicely. If I would have shown you this thing instead and would, well, okay, the outer border is a little bit of a problem, but that this is kind of the keypad you got in your phone. And The 5 is the 4 square because it's in the middle. The 1 is bottom and right because it's in the top left corner, and so on and so forth. You'd probably be able to recall this not just for today, but probably in 4 weeks from now and in 3 years from now as well. So you'll be able to kind of grasp and understand this idea. And kind of the one thing resembles those things which might be useful, but they outdate pretty quickly. For large language models, this might be the prompting strategies. Whereas the other thing is kind of is the synonym for competencies applicable long-term. And those are the ones that typically help us understanding the underlying concepts and creating actual novel solutions and not just replicating existing work. And I don't know who of you remembers the transition from Word 2004 to 2007. I remember a lot of people saying, okay, screw it, they ruined Word. And I hope no one from Microsoft is here that could be mad at me. But I think this really shows how we get acquainted to specific features that are provided by the tools we're using. And that's a difficult challenge in education. And I think that's something that we want to avoid. So kind of we want to focus always on the underlying principles. We could call it the concept knowledge. And the concept knowledge is what we ultimately want to go to. Of course, we need to have some product knowledge, otherwise things don't become tangible. So we need to have something to operate with. But the thing we ultimately care of, if we look into employment, if we look into education in general, we want to get to this concept knowledge so that people, independent of the tool we give them, can figure out new and novel solutions and not just apply the hammer to everything. And with that in mind, the question, of course, is how can we do this? Like, how can we do education with a focus on this idea? And I just brought you a bunch of examples, I think, that can help. And I kind of specifically tailored them towards quantum computing. So one thing I think really helps is to make those things interactive and bring them to life through interactive applets and stuff. Another thing I've found to be pretty helpful is that using different frameworks side by side to highlight the concept, not just the code. So I don't know, in this case, it's Qiskit sarcasm. So the same concept, in this case, only had a mark gate, so it fits on one slide. But I think those things can really help to let people abstract away from what they type to what is the concept behind it. Because all of these tools, they include the concept. It's just sometimes that for us as humans, we need to spend mental power on processing what we visually see, which is the textual representation also. And to abstract away from this, using multiple software frameworks side by side can actually help. And the last idea I got is that in education, instead of kind of using advanced APIs and let people use those, go behind those advanced APIs, not AIs, and look into the underlying principles. It doesn't need to be Qiskit code like here, that's just an example, but it's the idea of giving people the concepts, because assembling then the solutions out of that should hopefully feel more natural to them later. And with that, I think I still have 1 minute of those 15 minutes left to give you also for questions. And well, with that being said, thank you very much for your attention. I'm happy to receive any questions. Let me know if I misinterpreted the task of the presentation. Otherwise, I hope you found it as interesting as I found the other presentations. And back to you, Samir, for like the Q&A.
Thank you very much. I will thank all of you for participating to this first workshop. We will organize other workshops on quantum computing. Thank you very much for these interesting presentations and the different point of view. And I hope see you soon. Thank you very much.
Thank you very much again to the speakers. Have a good day, everyone.
Bye.
Bye-bye. Thank you.
Thank you.